What's poppin', dogs? Mr. Allen here with some graphing in Polar. For this video, we got two different equations that we're going to graph on the same grid here. We got r equals 4 cosine theta and r equals -3 sine theta. First step I like to do when I'm graphing in Polar is identify what type of graph it is that I'm working with. Is it a cardioid, limousin, rose, circle, whatever? I don't know. For these two, they are both circles. How did I know that? Well, one, I don't have a sum or difference out in front here, right? It's not like 2 plus 4 cosine theta. So that rules out cardioid and limousin. And I also don't have a number in here with my theta. So that rules out rose, okay? Those are the things that we're going to look for in those other types of graphs. You'll see them in other videos. So for these, both circles. Now, you might be asked to plot a few points for circles. You may only be asked for a couple, or just use a couple of tricks. For example, my coefficient here, that's my diameter of the circle, and then the type of function we're dealing with, whether it's cosine or sine, will tell me the direction that it's going, okay? But we'll do a few points for this one. I'm going to do this guy here in green, and I'll throw a little t-chart down here, okay? And we'll pick a few different theta values, all right? So r, and we got theta right here. So for cosine, let's say we got 0 for theta, right? So if I plug in 0 for theta, what would I get? Well, cosine of 0 is just 1, right? And 4 times 1 is 4. So we'd have 0, comma 4, 1, 2, 3, 4, or 4, comma 0. All right, cool, so I got a point there. How about pi over 2, okay? So let's do pi over 2 now for my theta. And when I do that, cosine of pi over 2 is just 0, and 4 times 0 is just 0. So at pi over 2, I'd be at the pole right there, right? The origin or the pole when we're talking about polar. Okay, well, what else could I do? Could I do, let's see here. How about pi? Let's try pi. Well, cosine of pi is -1 times 4 is -4. So I'd have pi, I'd rotate all the way around, but then it's -4, so I reflect over the pole, and I'm right back to this point. And if I do 3 pi over 2, that's 0. I'm just right back here. If I do 2 pi, I'm right back. So I'm toggling between these 2 points. Perhaps I have a circle going right over here. Let's investigate a little bit further, okay? I'm going to pick a nice theta value for cosine that's not one of my quadrantals. I'm thinking, let's see here, at pi over 3. Pi over 3. What does cosine equal at pi over 3? It's 1/2. What's 1/2 of 4? That's 2. So at pi over 3, I'd be at 2. And yes, if we went all the way around, we could even get this point right over here. It would reflect over that x-axis right there. So now I have this circle. And you could continue with some other ones, like with pi over 6, you'd get root 3 over 2. So then you'd have like 2 root 3, whatever that is. You could plug into a calculator, but eventually you'd get this. Oh, that was kind of terrible, but let's see if I can make up for it over here. Whee! There we go. All right. Eventually you get this circle shape off to the right, okay? So I think a lot of times what they'll just ask you for is that you need to identify that this is going to be my diameter here. This is 4, okay? This will be half that, right? It'll be 2 and 2. And they'll probably just ask for these 2 points. They may ask for a couple others. I think it helps when you're first learning it to kind of see where those other points would be and how if you just kept on doing the quadrantals, you'd get these 2 points over and over and over and over, all right? It's almost like a petal of a rose in a way. Anywho, cool. That's that one. Let's do, we'll do orange for this one. Let's do sine. Let's see what happens. We'll do a t-chart again, just because those are helpful to explore, you know, a little exploratory fun. So if I plug in 0 for sine, right? So sine of 0 is just 0, so I'd get 0. So I'd be at the pole here, or the origin. The pole would be the correct terminology here with polar. How about pi over 2? Pi over 2. That's going to be +1, right? Sine of pi over 2 is 1, times -6 is -6. So at pi over 2, when I'm up here, I got to reflect over the pole to -6. And then how about pi again? We'll just kind of roll the same thing, right? That's going to be 0. So I get 0 again, not 6. There we go. So I'm back here. And if I did 3 pi over, like the same thing would happen. 3 pi over 2, I'd get -1 times 6 is +1, right? So then it's doing the whole thing, okay? So it's opening down. It's a circle opening down. And I could even do the same thing with those points, except for this time I'm probably going to want to use, let's see here. How about pi over 6? Let's do pi over 6. See what happens there. So if I do pi over 6, sine of pi over 6 is 1/2. 1/2 times -6 is -3. So at pi over 6, I'd be at, not at 3, but I'd be at -3. Yay! And the same thing would happen over here. And now I have this circle. I have to be quiet while I while I make my, my path there so it looks circular. But there we go. Again, I think usually these 2 points are probably optional depending on your teacher. Definitely need the one at the pole and then the other one as the direction that it's going. Since it's negative, it's going down. That makes sense. If it was positive 6, it'd be up here. And the same would go with the cosine. If it was negative 4, you'd just be reflected this way and you'd have a circle going that way. Cool? All right, so there we go. That's circles. Not a whole lot to them other than identifying what they are. I think the other ones are a little more complex. The limosol, cardioid, and roses get a little more into it, right? But there we go. Circles. That's dope. Fun. Awesome. Fantastic. And wonderful.